we draw a Lewis structure of something that's not a neutral compound. So when we drew carbon tetrafluoride, 1 carbon, 4 fluorine, that was a neutral compound. It had the same number of protons and electrons. This is a polyatomic ion. We'll talk a lot more about them in the next chapter. But what we have here is a sulfur that is covalently bound to 4 oxygen atoms, and then the whole thing overall has a -2 charge. Now, jot this down on your paper, don't yell it out. If it's got a -2 charge, does that mean that it has given up 2 electrons or taken on 2 electrons? Jot down. Jot, 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 jot. Compare notes with the person sitting next to you. Okay, what do you think, Grant?
Gain.
It's gained 2 electrons. Because remember, electrons have a negative charge. If you have 2 more electrons than protons, you're going to have a negative charge. So when we figure out how many valence electrons we should see overall, that's going to become really important, right? Okay, let's do our little tallies. So we've got sulfur and we have oxygen. How many valence electrons does sulfur have? Check your periodic table. 6. How many sulfur atoms are represented here? 1. So that gives us 6 valence electrons. How many valence electrons does oxygen have? 6. Because they're in the same what? Same group. How many oxygens are here? 4. So that gives us 24. So right now we're up to 30 valence electrons. Now what you do is you look at this thing and say, is it charged? If it is charged, we have to add that number of valence electrons. So that's going to be plus 2 valence electrons for a total of 32 valence electrons. Okay? Wunderbar. Now, we run into this weird little thing here. See, I'm giving you all the weird situations. We have to figure out what's going to be in the middle, right? So what are our rules so far? More electronegative or carbon. Do we have carbon? No. Which of these things is more electronegative? Oxygen. Well, here's the conundrum. If we have one of one thing and multiple numbers of something else, the thing that we have a single atom of will be central. Despite the fact that, yes, oxygen is more electronegative, sulfur is going to end up in the middle. They're relatively close in electronegativity, but whenever you have a single atom of something and multiple atoms of one other element, the one that you have a single atom of will end up in the middle. Okay, so let's draw our Lewis dot diagram for sulfur. We'll stick sulfur right here. We have 1, 2, 3, 4, 5, 6. I'll do that just for sort of grins and giggles. Now we know we have 4 oxygens. I see a problem. Do you see a problem? Okay. What's the problem? There seem to only be 2 sides where sulfur can bond. That's disturbing. Okay, well, it's really easy to see where the first 2 oxygens bond, right? They're going to slide right into these little slots, and we're just going to do this. And we can replace those with a nice single line. We still have 2 more oxygens. Now, intuitively, you might have some sense that since there are 4 of one thing and 1 of the other, and we show 4 sides, you might think, well, the oxygens must go on those other sides. I mean, no, you would think that they'd go on the other oxygens, huh? No? What would you think?
I would think that they were trying to do like a triple bond.
Okay, we are going to form some multiple bonds here. We are going to form some multiple bonds. Okay, so what's going to end up happening is this moves up here, and we form double bonds. Okay, so we now have that situation. Oh shoot, no. No. Tell you what, doing these is tricky. And I never managed to get through these without screwing it up at least once. Okay, here's what happens, that's right. I don't. I'll be perfectly honest. So when I tell you that you're going to screw these up when you do them and there's a little bit of trial and error, I mean it. I make mistakes too. And I just made one. That doesn't form a double bond. Doesn't form a double bond. Erase that double bond. So what will end up happening is we will end up with oxygen sharing a pair there. Oxygen still has, let's see, 2, 4, 5, and it's sharing there. It's still got 5 of its own that it's not sharing. Okay, so these are single bonded. Now, something's got to happen here. So first of all, let's check and see how many valence electrons we have represented. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25, 26, 27, 28. We're up to 28 valence electrons. Why 28? If you remember, that sulfur already had 2 top and bottom. So some of those have moved around. We'll finish this up, I guess, on Monday.